Welcome to our first presentation of this term about our project design and control of assistive exoskeleton new mechanism.
In this presentation, we are going to talk about brief reminder of the project, market and technical requirements that we determined last semester, improvements done and their results, schedule and task distribution for this semester. According to research by TÜK in 2010, 8.8% of disabled people suffers from orthopedic disability. In context, there is 1 billion disabled individuals on Earth and approximately 1.5 million on Turkey. 8.8% of that number runs up to 125,000. Furthermore, market for our project has a high price tag such as $75,000 and less variance compared to the USA, United Kingdom and United Nations. There is another motivation for us, which is elderly people and heavy workers. Gathered data from the TÜK stats in 2017 shows us there is at least 7 million individuals whom are older than 65. If we consider the life standards and medical technology in the near future, 2050, this number will be doubled. And this project can be improved and adapted for certain works, which can lead to lower chance of deformation and diseases in the legs for heavy workers.
The main purpose of this project is to help elderly and disabled people to simplify their daily lives, such as sitting down, getting up. The project plan is shown on the left. We are using both of spring and brushless DC motor to support users' muscle, and we are using pressure sensor on foot sole to determine users' intention.
The project needs to be capable of working up to 120 kilograms. Pressure sensor must measure up to 200 newtons. Weight of the project must be less than 1 kilogram. Speed must ensure to be provided at 12 RPM. Total cost must not exceed 5,000 Turkish liras. Disability assist rate will be up to 50%. Operation range will be between -150 to -270 degrees. The project must be reliable, precise, durable, affordable, and safe. It needs to increase the mobility of the user and needs to be easily implemented and compatible. Here's the free body diagram of our project. And for the mathematical model, we can think of our system as just DC motor and external torque produced by spring to the system. You can see the mathematical model and necessary calculations. If we take the Laplace of the first equation, we can get the transfer function after doing necessary transformations. There are different ways of controlling a DC motor, such as speed and position control. Torque control, which we used in this project, can also be used as a control method. In this control scheme, the system will try to reach the desired torque by computing the error and including it into initial desired torque. Although the advance of many complicated control theories and the techniques, most of the industrial processes currently are still controlled by proportional integral derivative controls. This shows that this very simple control technique has great potential for fulfilling the needs for many industrial processes. Here's the Simulink control scheme. This is the input of the system. And motor torque is shown on the left, spring torque shown on the right. Here's the both output and spring torque in the one graphic.
We are going to design a basic 3D printed prototype for testing and obtaining any failures or design flaws. If there is any failure on the main product, which is going to have an aluminum body, it will be expensive and hard to repair it. For our main design, we have not made any changes from our previous semester design. This basic model also will be used for testing the motor and the gearbox efficiency and gearbox design flaws. The prototype model will not include straps that are integrated with the clamps, as shown on the left. It will rather have the straps nailed on the clamps. When we make the prototype that has not have any of the before mentioned flaws, we are going to start testing for the spill spring. After all of the tests have completed, we are going to build the project with the established materials from the previous semester. Here is our prototype's main frames and technical drawings of it for it to be 3D printed. Here is prototype's lower clamp and the technical drawing of it for it to be 3D printed. And here is the prototype's upper clamp and technical drawing of it for it to be 3D printed.
We use pressure sensor to obtain user intention. This sensor will be placed under user's leg. Force sensor will be used with neural network for the determination of the intention. We choose Maxon EC60 flat motor as our actuator. After that, we choose a gearbox which can give sufficient torque. We justify our calculations from the previous semester and come to the conclusion these are correct. Here's our electronic schematic. Here's our electronic circuit. Here's entire schedule of our project. We are now in the stage of supplying the necessary components and manufacturing of mechanical parts according to our schedule.
I will be designing control card and implementing the algorithm and testing it.
In this semester, I will be working on the mechanical design again. I'm going to start testing and analyzing our prototype with our electrical and control systems. If there is any flaws on body design, I will fix them. If there is no problems, I will start working on the main aluminum body.
I designed electronic circuit of this project. I will working on testing the sensors, implementation of electronic circuit, and neural network to determine user's intention.
We got the TÜBİTAK 2209B financial support. And our pre-application is accepted by Technofest. Here's our references. Thank you for your attention.